next type of force we're going to think about is upthrust. If you get into a bath filled with water, the water level will rise. This is because you have displaced the water. You've pushed it out the way to make space for you in the bath. This is why the water exerts an upthrust force on you. Similarly, if you have a helium balloon, the air that used to be here has had to get out the way to make space for the balloon. The balloon has displaced the air, and so the air exerts an upthrust force on the balloon. All the upthrust forces you will deal with at A level will be upwards. If you want to get an upthrust force that's not upwards, you've got to really try quite hard, but you can do it if you take a helium balloon in the car with you as you drive around a roundabout. In the next two videos, we're going to deal in detail with upthrust calculations, but here I want to look at how you might measure the upthrust experimentally. So here's my object, it's just a block, and first of all I'm going to hang it from a Newton meter and read the tension in the Newton meter. So my force diagram is just this. If my block is not, it's stationary, so it's not accelerating, so that whatever the tension reading is going to be equal to my weight. So let's just say that the weight of the block is 4 newtons, and this is how we work it out. Next, we're going to lower the block into some water, and so now this is our force diagram. We've got an upthrust force on the block, exerted by the water, and so the tension force doesn't need to be as big. My block is again stationary, so not accelerating, so all the forces are adding up to 0, but the tension force doesn't need to be as big now, so the reading on the Newton meter will be smaller. So let's just say that now the Newton meter reads 3 newtons. Okay, and so that's it. So I can now determine what the upthrust is. It's going to be 1 newton.